Hi everyone, here I am going to discuss about nature of carbon halogen bonds. So this is carbon halogen bond. So halogen is represented by the symbol X. Okay. So when I say halogen, it is group 17, fluorine, chlorine, bromine, iodine. Okay. So now we have to learn some of these few things. That means as we go down the group, size increases. That means this iodine will have the greater in size. Fluorine has the smallest in size. As we go down the group, atomic size increases. Now let's talk about this carbon and halogen bond. So see, if I talk about carbon bond, these both are carbon, so they do not have any electronegative differences. They do not have any electronegative differences. That means if I show in the form of electrons, the two electrons are at the center, mutually shared at the center. Now if I change this bond, in the form of carbon and halogen, see, due to this electronegative in nature, it will have the tendency to pull the electron towards itself. So now the electrons will be somewhat shifted towards the halogen group. So due to this electronegative in nature, the electron is somewhat shifted towards the halogen group. So due to that, there will be arise some partial negative in nature, and this will have some partial positive in nature because the electrons will shift towards the more electronegative element. Now, due to these electronegative differences, what it arises is that the bond will be polar in nature. The bond will have polar in nature, and due to this polar in nature, it will have some dipole moment. It will have some dipole moment. So the nature of the carbon halogen bond is, we can say that it is polar in nature. Okay. So now let's talk about this carbon halogen bond. Okay. So when I talk about halogens, so it will be different halogen. It can be fluorine, it can be chlorine, it can be anything that is in the group 17 carbon iodine bond. Now see, as we go down the group, atomic size increases. So this part is fixed. This part is fixed. Let us fix this part, carbon part. Okay. Let us fix this part. Now, as we go down the group, atomic size increases. That means the bond length also increases. That means the bond length also increases as we go down the group. Carbon, fluorine, carbon. That means carbon iodine will have the longest bond length. Now, as bond length and bond energy or bond strength are inversely proportional, which let us check which one will have the highest bond energy. So this one will have the highest bond energy because they are strongly attracted to each other. They have shortest bond length relative to all this, comparing to all this. So this will have the highest bond energy. That means bond energy means it will require high amount of energy to break the bonds. Okay, now we'll have dipole moment. And also, okay, we are, by doing this, we can understand about the bond length, we also understand about the bond energy, we also understand about the dipole moment. So I'll show you here from the NCERT textbook. They have given it, the book has given some values here. See, CH3F, Cl, CH3Cl, CH3Br, CH3I. So the bond length increases as we go down the group. Because why? Because the atomic size increases down the group. And as we know that bond enthalpy, that means bond energy and bond length, are inversely proportional. So this has the less bond length, so this will have the highest bond enthalpy. Now talking about the dipole moment here, see, so when we talk about the dipole moment, more the electronegative differences, more the electronegative atom, more is the dipole moment. So here, which is the more electronegative in nature? Fluorine. Okay, but here see, there are some range. As we go down the group, the atomic electronegativity also decreases, dipole moment also decreases because the differences become less, the electronegative differences become less. But here there is some varies here. It is expected to be what? It should be lower, but it is somewhat high. 1.84, it should be lower, but it is greater, which is unexpected. So why it happens is because the distance value of CH3Cl is large.